Well, good morning. It's November here in New England, and I see the harbor is thinning out considerably. So I think it's a good time to talk about the most common question that I get, and that is about heating Charis. I'm going to start this discussion with my most steampunk and experimental heat solution, and that is the one I call the toolbox heater. So we're going to take a deeper dive into that today and see what it looks like. So Charis's three primary heating installations, those being the wood stove, the Wallas forced hot air diesel heater, and the toolbox heater here. This is by far the least costly of the three as far as installation and build is concerned. This is also the most portable and removable of the heat sources, my primary heat sources. The heater itself in its toolbox enclosure sits on the bridge deck. The hot air is ducted in on center line, and the return air from the cabin goes through a hose and back into the heater on the starboard side of the companionway hatch there. What I've done is, and the fuel tank, by the way, is separate from the unit and is plugged in externally. And so what I've done is I've divided the lower companionway drop board in half. The lower half of that is this board through which the intake and return and supply air are provided into the cabin. And then there's a plexiglass half board that fits above it. Above that is just my normal plexiglass drop board. The controller and power wires are run in below the partial lower drop board that has the return and supply air duct. The controller is just mounted here or tucked in above the EPIRB on center line, and then the power wire is run underneath off to the starboard side. That goes into the same plug it shares with the portable solar panel. So we unplug the portable solar panel, we plug in the toolbox heater. One thing that's important to note is you do not want power to be interrupted to this unit while it's running. That can lead to an overheat situation. It has a shutdown process that it needs to go through to cool itself off. So I've built this little bungee cord seat belt to keep the plug inserted. So that's the basic install. The function is pretty simple. Wake up in the morning, about an hour before I want to get up, find the little remote control key fob, hit the on button, let the unit start heating up the cabin, and go back to sleep or read the news for an hour and get up to a nice warm cabin. I only let this run overnight if the temperatures are expected to be sub-freezing to where I expect the cabin temperature would get dangerously low. And so let's head over to the shop now and take a look at version 1.0 of this heater. So let's take a little bit of a deeper dive into the toolbox heater, and I want to talk a little bit about why instead of buying one of the packaged overland heaters that are available more or less for the same price as I paid for all these components, I decided to build my own unit, just a little bit better suited to my intended application here. So what you're looking at here is the version 1.0. The one that's on the boat right now is, I would call it 2.0. One of the best quotes that I saw online when I was looking at these is in one of the reviews. It said, you're not buying a heater, you're buying a hobby. And to that extent, there's a certain amount of truth. What you see here are two that initially I purchased at the lowest price they were available for on eBay. It was probably about $88 or something crazy. The first one did not work. They did not want it back. They sent me a second one. It didn't work either. But by taking the two apart and gaining a master class lesson in what they look like inside, I was able to reassemble one working unit that's now in this toolbox and get it up and running. In the meantime, I had purchased the next lowest price unit for about $100. That's the one that's on the boat now. It worked straight out of the box and has not missed a beat. Very similar inside, but I will say that these control units do vary, and so I could not plug this controller into the one that I'm using right now on Charis. However, I do have two controllers for this one since I got two complete kits. Anyway, that's what you deal with when you're dealing with these very low-priced sort of knockoff bus heaters. So, fair question. Why not just install this on Charis as my main heating system? I mentioned in some of the earlier videos that my main heater is an installed Wallas in the wet locker between the main and forward cabins. That unit is far superior in many ways for its purpose to the use of one of these. The one thing about that unit that is not superior is that it can only be serviced in the US in Seattle, and every time I have to send that unit out to be serviced, the shipping costs equate to buying about 2 of these, and that's before any repairs are done. So that's a very expensive unit to maintain. It works really well. I really like it. But part of the process that I started with these bus heaters was to see if there was a way that I could use one of these as a redundant system that could be used while the Wallas is out being repaired or replaced. You know, these units do have a shelf life. They last a certain amount of time, and then the fans start to go bad and other things inside. So you got to figure that at some point, if you're using them for more than casual weekend use, you're going to be replacing them. So why not install a bus heater as a primary heater on Charis? Notice that I call these bus heaters because that's really what they're designed for. That's why they're inexpensive, relatively speaking. There are a lot more buses that buy these than there are boats. These units are designed to heat a road vehicle that is larger than can be effectively heated by waste engine heat. So they're a ubiquitous solution for RVs and buses and large road vehicles. As such, they are designed to be mounted and installed just as you see this one. In other words, with the air intake and the exhaust and the fuel pipe coming up through the bottom of the unit, and the unit, in this case the bottom of our bus would be the top of this milk crate. The unit is installed in the floor. That works really well because heat rises. So installing this in the floor of your RV or bus, you can lead your exhaust directly out, you can take your intake air in from outside, and your fuel lines, which probably already run underneath the vehicle, would be run that way. Simple, works great. Everything goes downhill. Well, not so simple on a boat. Unless you're talking about mounting this high up in a power boat, downhill is water. So typically what happens with these is they have to be installed in a location where the exhaust pipe at some point runs up from the heater to the transom or the deck or however the side of the boat. That introduces the possibility of water flowing back down into the heater. The heater is now at, if not the low point, certainly below the exhaust exit point. And my feeling is that that's why a lot of these units tend to fail, that water backs up in there, water vapor from the combustion process gets trapped in the exhaust lines. Generally speaking, this unit would like to be mounted above the water line and above the exhaust discharge, but that's relatively hard to do, particularly on an older sailboat with low freeboard like Charis. So what's the solution for that? Well, in this case, because I was doing this as a redundant system, I wanted it portable. I wanted it built into a transportable case that could be taken off the boat for most of the year. In fact, taken off the boat at times it doesn't stay on board at all because I'm using the Wallas or the wood stove. So this is an easy thing to store in the shop and grab when I need. And to that end, I decided to build this into what's essentially a Harbor Freight plastic ammo can / toolbox. This one may have been a Flambeau tackle box. I'm not sure, one of them was each. But anyway, it was the perfect size box. It's plastic. It has a gasketed lid to keep the weather out. These units can take a little bit of weather exposure, but certainly not being mounted outside in any sense. So why not buy what is commonly known on Amazon or eBay, an overland heater, fully set up. They're inexpensive. There are a few different brands. There are subtle differences between them. And essentially you got a package that's plug and play. There are a few reasons for that. First of all, pretty much every one of those units exhausts downward, which means that it's installed in this orientation, which is the design constructed orientation for the heater. But by exhausting downward, that exhaust stream in an overland heater on a boat would be coming straight down toward your fiberglass deck. Now, if you're using that outside of a tent in a campground and the ground is dirt, that's not a problem. If you're taking 900-degree exhaust gas and pointing it straight at your fiberglass, you could very well be creating a problem, and a big one. So straight out of the gate, the downward exhaust feature of the stock overland heaters was somewhat of a deal killer for me. Second reason, on the overland heaters that you see online, this control unit is generally mounted right on the box. Okay, this is not weatherproof. This is your thermostat if you choose to use this in thermostatically controlled mode. And even though you do get a remote with these, by putting the thermostat outside, it's useless. It does nothing for you. And for most of those heaters, I certainly would not leave them outside in heavy rain because you'd probably be pretty much shorting out this control unit. So I know there are some online hacks to take that off the unit and relocate it inside. There may be someone now manufacturing one where the control unit has the ability to be extended inside. My solution was simply to take the wire to the control unit and put a 3-pin quick connect on it, install the female end of the quick connect on the box, and then I run this inside the cabin of the boat when I'm using the unit. So it gets it out of the weather, allows it to sense temperature. As far as power is concerned, I opted to use a lighter plug since that's the standard 12-volt outlet I have on the boat. And on the outer end, I got one of these allegedly weatherproof quick connects that snaps onto the box. So as far as the overland unit heaters go, as I mentioned, I wanted the exhaust not to go downward toward my deck. I wanted the controls to be inside the boat. I also did not want the fuel tank to be integral to the unit. And that is because when I'm underway, I take this unit and throw it in a locker. Now, diesel isn't horrible to have below deck, but in the packaged overland units, what you're going to find is that usually there's an open vent in the diesel tank that's built into the box with the heater. That open vent, as you start heeling and rocking and rolling, is going to create some diesel spillage, I would think. So my solution was these motorcycle quick connect fittings, which I then built into the various fuel tanks, and I'll get to those in a minute. So you've got a male and a female quick connect. You've got your fuel tank that lives on deck, and you simply plug that in when you're ready to use the unit. So on the subject of the hot exhaust, what I've done on both of these, this is slightly different than version 2. The flex pipe is a pre-made length, so I wasn't able to shorten it. But essentially it runs out the back in this S shape, and the stock muffler that came with the unit, which does quiet it down quite a lot actually, just slides into the pipe. And that whole thing just runs out on deck. Works fine. You do have to let it cool off before you put it away, but it was sort of a solution using the parts that came with the kit. But you do want to wrap this. This pipe can get very hot. So there are a couple of great online sources on YouTube for guys who really got to understand these heaters, and hats off. Particularly David McLucky. He's got one of the best sites as far as information on these. I don't think there's anyone on the planet that understands these better, but there are a couple, and I will put links to their YouTube pages in here because they get all the credit for getting me up to speed on this. So here's the inside of the unit. Now this is the 2 kilowatt model, and that was very specific because I wanted one that fit in this size toolbox. If you decide you need more than 2 kilowatts of heat, you're just going to have to get a bigger toolbox basically. So the first step here, seems to be stuck, was in coming to understand what is in this unit. What you have here is essentially a single electric motor. You have a fan on the outside of the motor housing that pulls air from your cabin through this unit, passes it over this heat chamber in which diesel fuel is being burned, and out the other end. So your hot air is coming out this end. Your return air, or your outside air, depending on how you use this, is coming in this end. You have a control circuit board here, and these boards are specific to the controller that you have. So while many other components on these will be standard throughout the unit, that controller, circuit board rather, and that controller will need to be a match pair. You have an aluminum cast chamber. Inside of that chamber is a stainless steel combustion chamber. So this is the heat exchanger. There's a stainless steel tube within this. This houses a glow plug. The glow plug is essentially a ceramic heat element used to ignite the fuel when the heater starts. So these heaters, when they start, will draw somewhere around 5 or 6 amps, at least the 2 kilowatt, while that glow plug is red hot to ignite the fuel. After that, the fuel essentially continues to burn. Important to note that these heaters do not cycle on and off for temperature. They cycle up and down. In other words, once this heater is turned on, there is enough combustion maintained to keep it running regardless of where the thermostat is set. It just goes down to the lowest setting when you hit your set point, and then it goes back up as needed to maintain that temperature. So glow plug, about 5 or 6 amps to start. Once the unit's running, at half speed, these use less than 1 amp, which means they're really easy on your battery bank. So the key to being able to build mine differently, as I said, they're meant to be mounted exhaust downward, and as you can see, my installation is mounted exhaust sideways. Why does that work? The reason that works is that the fuel is injected at the base of this glow plug. So as designed, the fuel is injected in this top corner, and there's a breather hole there to allow air to get in. If you run it in this orientation, the fuel is always going to go downhill. And the worst that'll happen if you get a flame out is fuel will end up in the combustion chamber. Well, you can see that if you rotate it 90 degrees in the correct orientation, that fuel inlet is still on top. So the fuel is still going in the top. Any dripping fuel would still end up in the combustion chamber. Obviously that would not be true upside down, nor would it be true rotated glow plug down. So short explanation that I learned through YouTube University is glow plug up. And glow plug up, I can tell you from my experience, whether it's on that corner or in that corner, functions perfectly well. So, hence the problem of exhaust flowing downward toward the deck is solved. The exhaust now flows out the back. And what you'll see here is that I've done that by using this mounting plate that came with the unit, meant to go in the floor of your bus or RV. And the idea is to cut a wide enough hole so that you don't heat up your floor. So you've got the some distance between the exhaust outlet and the edge of your cutout. Well, I simply took that plate, cut it down to size, and bolted it into the side of the plastic toolbox. In this case, the toolbox is cut far enough away from that exhaust port that it doesn't build up too much heat. This is a good time to mention too that when these are running properly, it is not hot inside this box. In fact, I would call it warm, if anything. And I do tend to store things like these rubber end caps that I use when I'm not running the unit, just to close off the ends. I'll store those inside there with absolutely no problem at all. The key here is that you can mount this unit on its side as long as you mount it with the glow plug rotated upward. So a few words about user serviceability, which is something that I particularly like in a product. The Wallas heater's user serviceability is near zero. There's very little that you can do on the Wallas without specific diagnostic equipment. These units have become so ubiquitous that while user serviceability may not be on a technician level, serviceability on the level of parts changer is actually really easy. The circuit boards are plug and play. The motors and fans, even between the two different units I have, are identical, as are the combustion chambers and the heat exchanger housings. So there's a lot on these. It wasn't my intention to end up with a spare unit, but because of the failure out of the box and the need for me to assemble one good unit out of two, I now have a lot of spare parts. And at the end of the day, I suspect that the ultimate failure in the one that I just never got to work, which is this one, is just a very poorly, very crudely made combustion internal chamber. So pretty much I've got a glow plug, I've got a circuit board, I've got a lot of spare parts here. So the one feature from the Overland heaters that I did keep was the idea of mounting the fuel metering pump inside the box with the heater. Now again, that only works because this box never truly gets hot. This entire heater cover housing is plastic, so the design of this unit is such that there's enough airflow through it at all times to take any heat that's generated in here and shoot it out the end and out of this box. So if this box doesn't get hot, the original casing of the heater, then obviously neither does the toolbox. And that incidentally is another advantage to the unit being on its side and exhausting out the side. The Overland units you buy with the exhaust going downward have a 90-degree bend, and they tend to put a lot more heat into the casing. So you'll see most of those have vents. Some even have fans to keep the inside of the box cool. This works fine. It works quite well, actually. Now, these metering pumps do have a clacking noise that some people dislike greatly. There is also a fuel filter way down in the bottom here that's installed right within the box, so that you're running your fuel line out and then out to the heater unit. This gooseneck that you see, this black fitting, is your air intake for your combustion air. And this, of course, also is completely external. There's a sort of an air baffle here that quiets it down a fair amount. And I think it also keeps any rain from getting sucked up in there. That works quite well. It's a little vulnerable. It's a little fragile. I do have to be careful when I'm throwing this thing around not to beat this up, but easily fixed, easily repaired. And I'd point out one other advantage doing it this way with the fuel line external and then running into the side of the heater, which is intended to be the bottom. You will see immediately if there's an interruption in the fuel flow. So if the heater goes out and it sounds like it should be running, the first thing you look at is to see if this is full of air bubbles. And all of these have a process for purging that air. In this case, it's very easy. I pull the line right off here, put it in a little bucket, and run the purging process until all the air bubbles have disappeared from the line. So as to the specific fitting of this unit within the Harbor Freight toolbox, I want to point out that what I chose to do was to take the product hot air side of the heater and install it through the side of the toolbox, so that when I connect the hose that goes into the cabin, it's connected directly onto the heater outlet. On the inlet side, because obviously you need some room to place this down into the box and then through the side, and that is a little bit of a fiddly procedure where you've got to kind of squeeze and tweak the box a little in order to get the mounting studs through the plate, but it does work. It's not impossible. So on the air intake side of the bus heater, what you'll see here is I've left the original intake cap screen on, mainly because that holds this unit closed. So it's drawing air in from within the box, but then to get air from outside or from a hose, a return air hose, which I prefer to use, I've got this fitting mounted through the side of the box. This is essentially a vacuum fitting. That's a 2.5-inch OD fitting that is intended to be used for an installed shop vac system. These are available all over the place, Home Depot or online in this case. So that fitting is mounted through the side of the toolbox. And as I say, this can be used in a couple of different ways. You can simply let that draw product air in from outside and bring fresh air through the heater and blow it into the cabin. One caution on that is if you're mounting this, as I did, like in the cockpit, you will notice a little bit on startup of a tailgate effect where this is sucking in air here, but blowing exhaust out here. So you can get a little bit of a whiff of exhaust fume, particularly when it lights and before the combustion has become thorough and complete. So in doing this, you want to have this, if you're going to use outside air, I guess my point is, you want to put this in a place where there's very little chance of tailgate effect bringing the exhaust back to your intake. In my case, I find it preferable to just recirculate cabin air, so I will use a heater duct hose, 2.5-inch hose that goes from the cabin board back to the intake and recirculates the same air. Even the least expensive of these units all come with this little key fob remote control, which allows you to do basic function on, off, and up or down in the heat setting. Mentioned earlier thermostatic control, and that being one of the units that I want the control unit in the cabin of the boat. All of these also give you the option to run either at a set thermostat setting like in your house, or just at a particular heat setting level. One of the reasons I use a 2 kilowatt unit is because at full tilt, it's just about the right amount of heat for the volume of Charis's cabin. Now, if I were to put a 5 or an 8 kilowatt heater in, not only would it need a bigger box and take up more storage space, but the vast majority of its runtime would be at a low heat setting. Even with the computerized control, these units burn most efficiently at or near their top end. So if you put an 8 kilowatt unit in and you're running it at, say, 2 for most of the time, what you're doing is burning less efficiently, and that's going to result in carboning and essentially shorter cycle life for the heater. You're going to carbon up the inside. So my advice is get the smallest one that will do the job for your boat. And finally, a little bit about the tank. The version 2 unit that I have on Charis right now is running from my first tank, which is it's about a 1 gallon gas tank. This is the second tank that I built, and this was a store-bought kerosene 2.5 gallon container. I simply took the cap and modified it with a suction line and a vent line. And on the end of the suction line, on all 3 of the tanks that you'll see, is this quick connect motorcycle fitting. Works great. I've never had a problem with it leaking fuel or air. Really quick to connect, inexpensive, and it allowed me to standardize several different tanks that I've tried to the unit. And tank version 3, this was sort of the last word. I'll mention that these larger 2.5 gallon tanks came into effect once I got to a point where I trusted and used this unit for extended periods of time. The 1 gallon tank is more than adequate for, those cusp seasons where you're running it for an hour in the morning or 2 or 3 hours in the morning and evening, but not leaving it running for a vast part of the day. I find I have to refill the 1 gallon tank every 2 or 3 days. The 2.5 gallon tank will run this unit the way I use it for a week anyway. So this particular third version, I utilized the steel pickup fitting that's meant to go in the vehicle fuel tank. So it's a little different than the others in that regard. So the only modification that was necessary for the stock jerry can was to fit some gaskets under the flange that came with the automotive tank connecting kit. And there's my pickup. So this works really well. There's an added advantage that I already use this identical tank as the supply tank for the Wallas heater that's installed. So I had 3 of these actually. I always carried 1 spare that I could swap out on the Wallas. And now I have a spare for either the Wallas or the toolbox heater. It's the same tank. Well, there you have it. A lot of hot air about hot air. Thanks for coming aboard this week. I hope this little rundown of the toolbox heater, my least expensive heating solution on Charis. I think somewhere around $200 all in. Hope you enjoyed the rundown, and hope you enjoy the fall sailing, because the weather might be getting colder, but the crowds are getting thinner. We'll see you next week.